Hello guys, welcome. Our today's project is smart vehicle safety monitoring system with black box implementation. So basically in our project there are some safety features for car or vehicle with black box. So all the information of the all sensor is get fed into ESP32 or our SD card module. So we call that black box system. Okay, so basically we are using STM32 Nucleo board, and another one is ESP32. We can see here, this is the ESP32. So on STM32 there is a temperature sensor which we are communicating with I2c protocol, and which is used for the sensing the temperature of our engine, and then M2M MQ2, which is for alcohol detection. If the driver drunk, then a car won't start. And another thing was the door status. If the door is open, the car won't start. And another is the brake is applied or not, brake status. And on ESP32, we are using tilt sensor to ensure the position of our car, and then force sensor to find out the impact if if the car accident happened, then ultrasonic sensor for the detection of vehicle to vehicle distance, and the final is SD card module. The SD card module we are using as a black box, so all the data of this ESP sensors and STM sensors get fed into the this SD card module. So the communication between STM32 and ESP32, we are using the CAN protocol to send the data between two microcontrollers. And on ESP32, the motor driver is there. So for driving the four motors, we are using this driver motors. We are using the external power supply for this STM, ESP and motor driver module, which is 4 volt output and 2 ampere. So basically we are using to convert the power 12 volt to 5 volt 7805 transistor. So here we can see, if we can see here, we have used this transistor and capacitor to produce the 5 volt output. So 5 volt output is fed to ESP32 STM and motor driver. And the conditions on the sensors are MQ2 sensors. So condition is if the driver is drunk or alcohol detected, then car won't start. Another condition is for door status. If door is open, car won't start. Then third one is the ultrasonic sensor. The distance between the two cars are 22 cm, 30 cm to 20 cm. Then car reduce its speed automatically. And the distance between 20 cm, below than 20 cm, then car applied immediate brake. And then we come to this MQ2 tilt sensor. So tilt sensor we are using for the decline of the hill. So if at a particular angle car get tilted, then car speed get reduced automatically. Okay, so on four sensors we applied the conditions. Now we will see that SD card module, all data is fed to this SD card module, and the communication is communication between two boards through that CAN protocol. And this one is the force sensor, so we can measure the impact between the two cars or two vehicles, so how much the impact is there. So we will take a look on this practical implementation. Okay, so let's power up our car with this adapter. It will take time to configure it with Wi-Fi. So this is the regular mode. There are 4 modes: regular mode, high hill assistant mode, then emergency brake mode, and slow down mode. So we can see this emergency brake first with ultrasonic sensor. If I put the obstacle here, the car get stopped immediately. And if the distance between 10 to 30 centimeter, then car will apply the slow brake or reduce its speed. We can see here, this is the regular mode, and now I will put in the obstacle. So we can see here the car reduce its speed immediately as long as come to the sensor. Yeah, car gets stopped. So two conditions are proved. Okay, so the third condition is for MQ2 sensor. If alcohol detected at particular range, the car won't start. So now car is running. I will put some alcohol. Car gets stopped when alcohol detected. When gets sensor reading normal, it will start. We can see here. Yeah, car gets start because sensor readings get normal. Okay, so now we will see the tilt sensor operation. So now we will tilt the car to the angle. You can see here the car speed get reduced. We can see at tires at a particular angle car speed get reduced. This is feature is the high heels assistant mode. On hills it will very useful. So now we will look at door opening status. Okay, so this is now in regular mode. If door is open, now door is closed. At this position door is closed. If I press this, then door will be open and car immediately stop, or before starting, if the door is open, car won't start. So this is the okay, so car started. So this is for the brake, which is this brake data we are taking for this black box thing. So all the sensors data, the remaining sensors where we didn't apply the condition, that sensors we are using for that data of the vehicle. We can see the data through this SD card. We attach this SD card here. So I will show you the data of this. So now we are going to take the all readings from this vehicle. Okay. So we are applying the force. We can see this force applied, how much force applied on the sensor. Okay, so this is now I applied the force. Okay, so now I'll tilt the car. So we get the angle of tilt, the angle of tilt from x-axis, angle of tilt from z-axis. Okay, if the this is the emergency brake mode, this is the slow drive mode. Okay, this is the slow drive mode. The data is fed into this SD card. So now the door is open, status will be, flag will generated, door is open. Now brake is applied, now alcohol detected, flag is applied. Okay, so all conditions are proved. Okay, I will show with this SD card. So now I am going to put the SD card in my computer. Okay, so there is the number, index number. This is the date 2242. This is time. This is the ultrasonic reading. X-axis of our tilt sensor, Y-axis of our tilt sensor, then Z-axis. This is the temperature sensor reading. This is our MQ2 sensor, alcohol sensor reading. Brake is applied or not. Okay, regular drive. That's it. And this reading is for force sensor. So now reading is high. If we applied the force sensor, then reading gets slow because this is the register operating. Okay, So here we can see the regular drive mode. If a register get tilted, a tilt sensor get tilted, then high assistant mode on, and the value of our register is this, tilt sensor is this, and this is the hill assistant. This is the modes of our vehicle: emergency slow brake, then emergency brake, regular drive. I will show you the reading of our force sensor reading. Data appended is very fast. So here we can see the change in the force sensor data. This are okay. So on the MQ2 sensor, this is alcohol detector. So the starting reading is something 0, or starting from okay. So this is the reading 00280039 something. If we applied the alcohol, then it get higher, increased. It will increase till 500 or okay. This is the 339. So this is the all sensors data from our car. This is the date, time, distance of ultrasonic sensor. According to distance and hill status, our mode get changed. That's all. Thank you.